Hello. So last week I sent you this little slideshow and I asked you to read it. And yeah, some of you did, maybe some of you didn't. But I think I want to spend a little bit more time on this uh, this week because truly, kids, it is the basis for everything that we do in science. So here we go. I hope that I can move this as I talk to you. Maybe, yeah, there we go. Okay. So here are some terms that I'm going to be using, but I know it looks overwhelming, but truly, kids, I have given you the definitions right here. And so there's just a couple that I want to point out. Science is the knowledge about the natural world gathered systematically. Now, so you say, okay, Mrs. Strand, science, but there's a whole lot of scientists right now that are making a virus, or what do we want to call it? A vaccine. And you can't tell me that's man made. Well, no, it's not. But we take the things that actually it is man made. Um, we take the things from nature that we know will counteract the COVID virus, which is from nature. And kids, we're gathering that information systematically so that we can develop a vaccine. So that's kind of how that works. So a fact is a verifiable truth. In other words, kids, it can be proven. There's no point arguing it. An opinion is just a belief or a judgment. Kids, the difference between a fact and opinion, a fact, and I'm totally making this up. A fact, Keebler sells more chocolate chip cookies than anybody. I don't know. I'd have to look it up. But kids, an opinion, chocolate chip cookies are the best. Out of all the cookies, chocolate chip cookies are the best. Yeah, in my world, I don't know about in your world. Okay, objective means it's not influenced by personal feelings. Kids, I cannot be objective about chocolate chip cookies. Okay. Now, kids, I want to go over, let's see, on this one, kids, I want to go over variables. A variable is the thing that changes. So when we set up an experiment, kids, it's the thing that changes. And a dependent variable is what happens when you change something. An independent variable is the one thing that you change. Again, you only change one thing at a time. Okay? If you change too many things, how do you know what caused the end result? How do you know what caused the dependent variable? Okay, so kids, the variable is whatever you change. The independent variable is the one thing that you changed on purpose. And the dependent variable is what happens when you changed it. Okay, and then hopefully, yep, there we go. And a control, kids, the control is the thing that you don't change. You leave that the same. Understood? You've always got to have a control to compare back to. Okay? All right. Now, sometimes kids, these changes that we see are just teeny tiny. But if we don't have something to compare back to, we might miss it. All right. Let's see here. Hypothesis. Really, kids, that's what I wanted to go over today. Now, what is the difference between science and playing? Kids, in science, we write everything down. Have to. And no questions asked. We have to be able to do it again, and so we have to write it down. Okay, so let's take a closer look at this. I think that we're good here. I don't think there's going to be any questions. Systematically gathering knowledge. And so typically, kids, we use what we call a scientific method. But really, guys, is there only one method? The answer would be no. Everybody has their own way of doing things. And quite honestly, kids, every time you do an experiment, it's going to be a little different depending on what you're doing. Okay? Now, here's where I really want to focus today, asking questions. So, is it better to ask how rather than why? Kids, why? You can get into all kinds of arguments there. But how? Kids, we're studying this systematically. And so it's better to ask how. Asking questions that arise from careful observation of phenomena. Remember, kids, I told you phenomena is just a snotty scientific way of saying, hey, what's going on? Okay, so kids making observations. And how do we observe? With our eyes, with our nose, sometimes with our mouth, if I say it's okay, with our ears, and with our touch. Okay. Ask questions to identify and or clarify evidence. How did that happen? How did I get a flat tire? Okay, well, there's a question that we've got to investigate. Ask questions to determine relationships. Gosh, guys, do you think I got a flat tire when I went four-wheeling across the highway up in Red Lodge? Maybe not. But do you think I got a flat tire when I went four-wheeling across the rocky road that I drove on when I went up to Red Lodge? Oh, gosh, guys, that has a lot of possibilities. Okay. All right. We've got to look at the independent variables and the dependent variables in those relationships. So kids, on a smooth surface, probably not going to get a flat tire unless there's garbage out on the roadway. But in the rocks, oh yeah, some of those rocks are very, very sharp. Okay, ask questions that require sufficient and appropriate empirical evidence. In other words, kids, it's not opinion. You got to take a look at it, okay? You got to test it out. Ask questions that can be investigated within the scope of the classroom or the outdoors, at museums, public facilities. Kids, to ask questions about space. Gosh, guys, I don't have the connections to get your investigations up into space. You go up to the high school, kids, I know that Central High and Senior High both have connections to NASA, and they can help get your projects out there in space. Kids, I know that Rocky Mountain College has connections to NASA and can get your things out in space. I don't have those connections. So probably it wouldn't be a good idea to ask questions about space. Okay, now this is where I want to stop for today, I think. Yeah, okay, research, kids. You're going to have to do some research. You can ask other people. You can ask mom and dad. Write it down. You can go on the computer, but kids, be careful. Be careful. Get good sources. I don't know why I put the Minions on there. I love Minions. Okay. Kids, the hypotheses, play a bit. Seriously, guys, play with your materials. Find out what they can do. But when you go to make a hypothesis about your question, make sure to write it down. And here is a great little format. I think that when I put more chocolate chips in the cookie batter, this is going to happen. I think that they are going to be ooey and gooier because chocolate melts. I don't know, kids, but write it down. Okay. Here, kids, when we do our experiment, we talk about controls and variables. What does a control do? You would be right if you said it's the thing that we don't change. The variables, kids, are the things that change. The independent variable, it's the one thing that you did change. The dependent variable is what happened because you changed that one thing. Write it down. It can always be changed, but write it down. Alrighty, capturing data. Kids' pictures are a great way to gain evidence. Time it, measure the temperature, kids, but write it down. All right. Analyze the data. Gosh, guys, you can make charts and graphs. At some point, very soon, I'm going to be showing you kids how to record your data in Google and then making some charts and graphs. We'll go over that later. And then finally, kids, you need to present your information, present your question, your data, present your evidence or your data, okay? And then finally, present that conclusion to the scientific community. And in sixth grade, we are the scientific community, and we will judge your information. I hope this has been helpful. I have a little reading assignment for you to do, and a couple questions to answer in your virtual notebooks. But I hope this has been helpful for you.